Hi dear students. So in our last class we were discussing mainly as you know IUPAC naming system. So from this class onwards we will start discussing common names. Okay. So I hope IUPAC names are thorough for you. That is very important. These common names are not that very important. Sometimes a question may come from this, but you can understand this so that so you can feel confident while attempting all practice questions. Okay. That's very important. So coming to the topic, common names of organic compound. So here common names, another name of common names. Common means trivial, not very important. Okay, from that itself you will understand. So common names are also known as trivial names. Okay, so based on common names are basically classified based on their source and discoverer. So I will tell some history. So earlier actually there were only common names were there because initially when organic compounds they were discovered, it was discovered in various parts of the world. Maybe I can say during 1873 or 1900. Some organic compound got discovered in America. The same time it got discovered in Australia, or it may be some other places. So at that point of time the communication is not that well established actually. So in that case what happened is the person who discovers it, sometimes they may put their name actually. Okay, sometimes from where they have obtained this organic compound, based on its property they will put the name. So what happened later is there becomes a conflict actually, because people start discovering organic compounds, similar organic compounds, but their names were very much common actually. So what they formed a body that is called IUPAC, that is International Union for Pure and Applied Chemistry. What they told is, okay, after some years they put some guidelines to name an organic compound. Okay, so but still some common names are widely accepted by IUPAC. So please, that I have already discussed, I hope. So let us say, we can say common names are classified based on their source and discoverer. So based on their source we can say the common examples are CH4. CH4 we know it is methane, but earlier it was known as marsh gas. Marsh gas is its common name, for example. Why? It was obtained from marshy place. Okay, and CH3COOH we know it is what actually IUPAC is ethanoic acid, correct, but the common name is acetic acid. Why? Because the acetic terms it obtained from vinegar. Okay, now similarly HCOOH, what it is actually formic acid, right, or we can say methanoic acid, IUPAC. Okay, now formic acid, why the term formic came? Because it is obtained from ants, red ants. Okay, now similarly CH3OH, common name is methyl alcohol, and it is obtained from, it is also known as wood spirit. Okay, since it is obtained from wood actually. Okay, so I hope you got a fair idea. So here I cannot say any definite rule how to name this organic compound. That's why they say it's common names actually. And you people also know usually any individual has an official name as well as some pet names. So I can say official name is basically the IUPAC name, and the pet names are something called common names, and there is no rule in putting that pet name. It depends upon your father and mother, or your sometimes some children will be bubbly, they may be speaking a lot. So based on that they will put the name. Understood? So here we will learn some of the important common names, and that's it. Then we will go to the next topic, that is the agenda of this class. Okay. Now coming to the discoverer, so here I have tried to mention the two important reagent which is known based on the discoverer. First one is RMgX. R stands for alkyl group, any of the alkyl group, and Mg magnesium, and X is a halogen. So RMgX is it's a common organic compound, very important organic compound, and this is known by the discoverer who discovered it. It was Grignard, so that's why the reagent is known as Grignard reagent. And coming to the next one, dialkyl zinc, R2Zn. All these things we will learn in the upcoming chapters. So this is called Frankland reagent, since it was discovered by Frankland. Okay, so this is how we just give an introduction to common names. Next we will try to see the common names of saturated organic compounds and next unsaturated organic compounds, and we will also try to see how the radicals, monovalent radicals, bivalent radicals, trivalent radical, and what is a radical basically, how that is classified and what is its names. Okay, so I hope it is clear for you. We will just go to the naming of common names of saturated organic compounds. Okay, So next we are going to learn the common names of saturated hydrocarbons. So hydrocarbons are generally classified into two, that is saturated and unsaturated. We will come to that classification. So saturated means all sort of alkanes or single bonded compounds. Unsaturated means there can be double bond as well as triple bond. So the general formula of an alkane is CnH2n plus 2. This you might have learned in your lower classes, correct? Okay, so let's try to see what are the common way in which how you name an saturated hydrocarbon. Okay, so the first thing is here the alkanes, when you are trying to draw it, there can be branches or without branches. Okay, I will explain what it is. So first see unbranched alkanes, that is if there is no branch. Unbranched alkanes are named according to the number of carbon atoms. For example, if you have something like ethane, okay, let's say ethane, so how will you write CH3, CH3, and you know that there is no branches. So in this case it is based on the number of carbon atoms. There are two carbon atoms are there. So what is the term? It will be like ethane. Okay. And if it is only one, then it is we say methane. Okay. So if it is 3 means we will say propane. So if you see this, these names are very much similar to what your IUPAC names. That's why we say first 3 members of alkanes have only one structure. In that case, its IUPAC names and common names are identical. Very, very important. Okay. Now, there can be now the question doubt here is what is the third one? First 3 members means third means propane. Can I draw any other structure with this one? No. Whatever way, this is the only structure that is possible out of a 3-membered ring. Correct? Or not a 3-membered ring, not a 3-membered structure. Is there any other way you can draw it? No. Correct? So in this case, that is for methane CH4, and for ethane and for propane, this is called propane. IUPAC names and common names are identical. Okay. Now what happens? Suppose if it is butane, then the question is butane can have branching possible. Let's try to see how butane, for example, if I am drawing butane in this way, CH3, CH2, CH2, CH3. So you know this is butane. Suppose somebody drawn like this, CH, CH3, CH3. Now if you see here 4 carbon atoms are there. Here also 4 carbon atoms are there. So that means in 2 ways it can be drawn. Correct? So that's why if more than one structures are possible for a hydrocarbon, they are identified using prefixes like normal, iso, neo, secondary, tertiary. Now the question comes, sir, how I can apply these terms in this? That I will explain now. Okay, now you can think about in this case, in the case of propane, can I draw 2 structures like this, or a 3 carbon atom system can maximum drawn like this only? Because the carbon atom, the maximum valency is always 4. We need to satisfy the valency and draw the structure. So this is the only structure possible. Understood? But coming from the butane, you can draw multiple structures. So that's the reason why I say in those cases, we are trying to distinguish, but the base name is always what? Butane itself. But we will add definite prefixes like normal. So here we say this is a normal butane. Okay. Common name is normal butane. But in this case, what we will say, again this is butane, but we need to add some term in before that, prefix. So we say whenever there is one CH3 group connected to the second carbon atom of the continuous parent carbon chain. So in this case we use the term iso. So what is the term of this compound? What is the common name of this compound? That will be isobutane. Okay, or I used to remember like this. If you have a link like this, okay, something like this, CH3, CH, CH3, then we use the term iso. Okay, that is another way of remembering. Okay, next we will try to see how different structures and how we will assign normal, iso, neo, secondary, tertiary to these compounds. Okay. Okay, so we will try to see how to use the various prefixes, that is prefix n, normal, and prefix iso. Next we will try to see prefix neo. Okay, so prefix normal, when it will be used? So it says that it is used for unbranched alkanes. We know when is the unbranched, we can say from butane onwards the branching comes. So if butane is linear in nature, there is no branching, CH3, CH2, CH2, CH3. In that case, we use the term N-butane, or we say normal butane. And please remember here one thing, just something I have told wrong. If it is propane, we don't use normal propane. Why? Because propane does not have any branching itself. If branching comes, then only the prefixes will come into picture. Okay, so from butane onwards you need to remember this. Normal, it can be normal, or it can be iso, or it can be neo. So we will say how to use iso. So please read the definition. It is used when one methyl group is attached to the, when how many methyl group? Only one methyl group is attached to the which carbon atom? Second carbon atom of the continuous chain. Okay, let's see which is the continuous chain. So I can say my continuous chain can be this one, correct? So in that case, second carbon atom is this. Into that only one methyl group is attached. So in that case, I say this one is called my iso group. So we say what is this one? Again the parent name butane will not change. Why? Because there are altogether 4 carbon atoms are there. So we still say butane, but we know that into the second carbon atom one CH3 group is connected. So we use the term iso, or we say it is isobutane. Now when we will use the prefix neo, okay, I can say I am rubbing this. So if I say prefix neo, when to be used? Listen. So prefix neo is used, I can say it is used when instead of one methyl group we can say instead of one methyl group, if we are using 2 methyl. So it is used when 2 methyl groups are attached to the second carbon atom of the continuous chain. So I can give you another example for that. Listen. So prefix neo. So I am talking about prefix neo. So in the case of neo, I can draw the example CH3, okay, hyphen C, CH3 and CH3. So altogether 2 carbon atoms are 2 CH3 groups are connected, and if you have something like this, okay. Now many students will say, sir, here altogether 5 carbon atoms are there, right? So in this case, it is not butane, correct? It is, if 5 carbon atoms are there, what we say? It is pentane, right? So we say it is pentane, but what sort of pentane is this? So let me say the continuous parent carbon chain is this one, okay? Into this, if I number it 1, 2, second carbon atom has 2 methyl groups. If 2 methyl group comes, we use the term neo. So what is the name of this compound? We say it is neopentane. And what is neo group? I can say this is my, okay, I will use an alternate color. Okay, so this is my neo group. Okay, so this is my neo group. Without H, CH3, C, CH3, CH3, CH2. This is called my neo group. Okay. So I hope you understood. So 3 cases, one is normal, one is neo, and another is iso. Okay. Tertiary and secondary, it comes for applicable for radicals. Now neo means 2 methyl groups should be attached to the second carbon atom of the continuous chain. Iso means there should how many methyl groups should be attached to the second carbon atom? Only 1 methyl group. Understood? So I hope this convention is clear for you. Next we will go for the common names of unsaturated hydrocarbons. Okay? Okay. So next we are going to learn the common names of unsaturated hydrocarbons. Okay, so unsaturated means it can be of 2 types, which have carbon-carbon double bond as well as carbon-carbon triple bond. Okay, so first we will try to see compounds containing carbon-carbon double bond. So we know that compounds containing carbon-carbon double bonds, they are called alkenes, correct? So here the common name is alkylenes. Okay, alkylenes. Okay, and they are also called olefins. So here alkylenes means based on the number of carbon atom we will use the same way. Okay, for example, you have CH2 double bond CH2. How many carbon atoms are there? 2 carbon atoms are there. So if 2 carbon atoms are there, what is the term we use? Eth, correct? So lene is the term commonly appended here. So we can say this, that name of this common name of this compound is ethylene. Now you can itself say 3 carbon atoms are there means prop is the term. So we again use lean. So we say propylene. And what about this one? If you count, you know that there are 4 carbon atoms are there. So anyway, we know that 4 carbon atoms means but. So we say butylene. But you can say branching is present here. And I know that this is my continuous parent carbon chain, and into the second carbon atom, 1, 2, into the second carbon atom, 1 methyl group is connected. In that case, what is the term we use? Iso. Then what is the name of this compound? Isobutylene. And please remember, if you are not remembering that, this unit CH3, CH3, this is an iso group. Okay, that is another way to remember it. Okay, so I hope you understood. Next one, coming to compounds containing carbon-carbon triple bond. So here the general formula is CnH2n-2. So here the names are derived by replacing the hydrogen atom of acetylene by alkyl group. That means that all alkynes we are saying as a derivative of which one? Acetylene. Now if you have 2 carbon atoms minimum, then we use the term acetylene. Suppose here 1 hydrogen atom is replaced and 1 methyl group is introduced. Then what we say, as per the rule, they are saying names are derived by replacing the hydrogen atom of the acetylene by an alkyl group. So that means here 1H is replaced by which alkyl group? Methyl. So we can say the name of this compound is methyl. Then what is this unit? Acetylene. So the name is methyl acetylene. Okay. So coming to here, again we have 1 hydrogen atom replaced by a methyl group and another hydrogen atom replaced by another methyl group, and this is my acetylene unit. Then I can say 2 methyl groups are there. So whenever 2 methyl groups are there, what is the term we use? Di. Correct? So we can say this is dimethyl acetylene. Understood? So this is the way in which we name carbon-carbon triple bonded compounds. All these names are what names? Common names. Please understand. So sometimes in exam they may use this iso and what we can say secondary or tertiary. In some cases we use it in IUPAC, but not very common, and that is not very much correct also. In rare cases they will accept it. I will explain those miscellaneous examples as well. So I hope this is clear for you. Any doubt in this one, please come back in our doubt clearance session. Okay. So next we will try to see what are the different radicals, or what is a radical, and how we will derive the names for common names of the radicals. Okay. Hi dear students. So today next topic what we are going to discuss here is regarding the organic radicals, or what are the common names of organic radicals. So before I come to that, let me explain what is basically a radical. Okay. So very simple. You have can you consider an alkane, something like RH. This can be anything. For example, CH3H. We know this is methane, correct? So RH is basically an alkane. Now in this RH, if I am replacing one H, minus H means I am removing one H, then what will happen basically? I can say you will have R hyphen, and this species is called a radical. Okay. Now so similarly in the example, how I can write, one H is replaced, so this will become CH3 hyphen. So I can say this is a radical. Now what is its name actually? I can say this is methyl radical. And similarly, what will be the name of this one? We say alkyl. Understood? So this type of species, we call it as what actually? Radicals. Okay. So these radicals are classified into many actually. So we will first see what are the various classifications of the radicals, and we know that when a radical is formed during a chemical reaction. So during a chemical reaction, for example in substitution reaction, mainly this hydrogen will leave and you have the intermediate radical, and in this radical we know radicals are highly reactive species. Why? Because its valency is not complete. Now if you look at this example CH3 hyphen, we know that 3 valencies of carbon are satisfied, but the 4th valency is left free. So it will always try to become stable by combining with the other compound. So you can substitute here with any functional groups, like it can be cyanide group CN, or it can be amino group NH2, whatever be it. Okay, now we will try to see the various classifications of radicals. So first thing we say is the saturated. First classification that comes under here is saturated hydrocarbon radical. Saturated hydrocarbon radical. Okay, then what is next very important here is this saturated hydrocarbon radical, it can be of different types. That means I mean to say subcategories are there. So first one here is, this can be further classified into a monovalent radical. It can be classified also into bivalent radicals, and it can also be trivalent radical, trivalent radical. Trivalent radical. Okay, so we will try to see the examples of monovalent radical, then we will try to see the examples of a bivalent radical, then we will try to see trivalent radical. Okay, now I can say from the one example for monovalent radical is this CH3, this one. Okay, this one CH3 hyphen. So that means one H is, after replacing one H you will get a monovalent radical, and if I am going to replace one more H from this one, then this will become what? CH2. There will be two valencies free. If two valencies are free, we say that as what sort of radical? Bivalent radical. And if one more H is replaced, from this, means what will happen? CH, this will be like this. So this is an example for what actually? A trivalent radical. Okay, now we will see some of the important compounds and its radical name. Okay, we will try to see examples of monovalent radical. So as I have explained, we know this is CH4, correct? So if one monovalent radical means what actually? One H is replaced. So if one H is replaced, what it will become? CH3, this one. So what is the name of this one? I can say this is called methyl. Correct? Now similarly another one I will take, C2H6. What is this compound? Ethane. Correct? So if I am replacing one H, what will happen? C2H5 hyphen. So this is called what radical? Ethyl. Correct? So I could generalize that if one H is replaced, usually what is the suffix that is coming? YL. Correct? Eth for 2 carbon atom and YL is the suffix used. Now similarly, if I am coming to propane, for example CH3, CH2, CH3. Now I can replace H. Now here one question, big question here is, I can replace H from the central carbon atom or from the terminal carbon atom. It can be any of the terminal carbon atom. If I replace from this for last one or from the first one, it is the same. And from the central carbon atom, I will get a new species. Correct? So there are two possibilities. So let me say the first one is this one, CH3, CH2, CH2. One H is replaced from the terminal carbon atom. So what is the name of this one? This is called normal propyl. What it is? Normal propyl, because it is linear in nature. Okay, and please don't club the radicals with the other naming. So usually for radicals, what are the common terms used here is, we will use iso, we will use neo. Okay, sorry, neo is not used, sorry, iso, then normal N, then secondary, then tertiary. Okay, but for the common name of species, that is not radicals, for them we will use normal, iso and neo, and for radicals we mainly use normal, iso, secondary and tertiary. These are the common terms used. Now we will try to see where these will be used. So here you have seen, if it is linear we say normal propyl, Now what is the other possibility? From the central carbon you can remove. So let me write the other possibility is CH3, then CH, then CH3. So that means from the central carbon atom one hydrogen is replaced. So valency vacant will be at the central carbon atom. So what will be the name of this compound? So I can say this is isopropyl. Why? Because if I number it 1, 2, so you can see here I can draw this in another way. CH3, CH, CH3, correct? So if you see here you can see the linkage CH3, CH, CH3. This linkage you can see. So this is another way of drawing it. So this is called isopropyl. Understood? So this is called isopropyl. Clear? Now similarly we will try to see butane and what are the different possibilities for butane. Okay? Okay. So butane means I can draw the structure CH3, CH2, CH2, CH3. Now tell me from where and all you can remove the hydrogen. From the terminal carbon you can remove one hydrogen, correct? So you will get CH3, CH2, CH2, CH2 valency. Then what will be the name of this radical? Tell me. It will be normal butyl, correct? Why YL is coming? Because it is a radical. One H is replaced. Now what is the other possibility? You can remove from this carbon atom also, right? Because this is different. So I can remove from this carbon atom. So what it will become? So I can say the next possibility is CH3, CH2, CH hyphen CH3. Okay, now try to tell. Please listen. Here CH, both are CH3. That's why that linkage. Here you cannot see. Here one is CH3 and other is CH2, CH3. So can I say isobutyl here? No, not at all possible. So what I can say? This is called secondary butyl. This is called secondary butyl. Okay. Why it is called secondary butyl? Because this carbon atom is connected to two other carbon atoms. So that carbon atom is a 2-degree carbon. That's why we used to say it is as secondary butyl. Understood? Now we will try to see the next exam. These are the two possibilities in which you can remove hydrogen. If you remove hydrogen from here or here, both are same. From here or here, it is the same. So the two possibilities. For two possibilities, we have tried to see the name of the radical. Next we will try to see another compound, that is isobutane. For isobutane, what and all possible radicals are there? Because you know for butane branching is possible, right? We have seen that. So for butane, two radicals. Now we will try to see isobutane and what are the radicals. Okay. So let me say for isobutane what are the possibilities. Then it becomes easy or clear for you. So what we are doing right now, we are right now drawing the common names and we are trying to see the radicals under that, because this will be useful for you in many naming occasions and all. So isobutane means how you will draw that. You know that CH3, CH, CH3. This is the thing for iso. Then CH3 will come. So this is isobutane. Altogether 4 carbon atoms. So butane, and if in the second carbon atom there is this one is there, CH3 is there, means we say it is isobutane. Correct? This we have seen already. You remember in the common names. Okay. So how we will understand this, we will try to see. This is the principal carbon chain. So in the principal carbon chain, in the second carbon atom, if one CH3 group is connected, we say this as isobutane. I hope you remember. Okay, so this is isobutane. Now tell me, for isobutane, from isobutane, how many radicals can be generated? You can remove H from here, correct? You can also remove H from here, correct? But if it is removed from here or here, it is almost similar to the other one, right? So how many radicals can be generated out of this? Basically, I can say 2 radicals. So the first radical here is, listen, CH3, CH, CH3, CH2 hyphen. So what is the name of this radical? I can say this is called this is name is isobutane. So from this one H is replaced means what we say? Isobutyl. Okay, so this is called isobutyl. Okay, or you can remember like this. This is iso and there are 4 carbon atoms, so it is called isobutyl. And what is the other possibility? From here I have tried to remove. If I remove from here or here or here, you will get this species only. Or you can remove from this central, this carbon atom also, right? So what is that? I can say CH3, C, CH3 and CH3, this one. So what is the name of this compound? It is not isobutyl, because if you see in the second carbon atom there are more than one CH3 group connected. So this carbon atom is connected to one carbon, second carbon, third carbon. Since it is connected to 3 carbon atom, we use the term tertiary and we say this as tertiary butyl. We say tertiary butyl. So please learn this. This will be helpful for you. So I hope you understood the naming for monovalent radicals. Up to butane we have tried to understood, and next we will try to see bivalent radicals. Okay. Okay, so next we will try to see what are bivalent radicals and examples for that. So when I go to bivalent radicals, the thing is you can remove 2 hydrogen, correct? So from where and all these hydrogens are removed, based on that it will be named accordingly. For example, let me consider this compound. What is this compound basically? CH3, CH3. We know that this compound is ethane, correct? Ethane. And you know that whenever 2 hydrogens are replaced, this will become a bivalent radical. So one possibility is what actually? I can remove the 2 hydrogen from this carbon alone. Then this will become what? It will become like this. Correct? What is the other possibility? I can remove the 2 hydrogen, one from here and other from here. Is there any other possibility possible? No. Correct? So 2 hydrogens are replaced but from the adjacent carbon atoms. Here it is from the same carbon atoms. So based on this, this will be named accordingly. So if the 2 hydrogen atoms are replaced from the same carbon atom, we use the term alkylidene. What is that? Alkylidene. And if it is from the vicinal carbon atom, vicinal means adjacent, that is from the 2 different, it should be near to, that is very important. If it is very far away, not possible, it is near to carbon atoms, it should be the adjacent carbon atoms. From the adjacent carbon atoms, 2 hydrogens are replaced, then we use the term alkylene. So one is alkylidene, other is alkaline. Okay. Now we will try to see various examples and we will try to name it. Okay. So this is also easy actually, but this is very important also. Sometimes they could ask for the exams. Okay. So let's start with, okay. So example, so tell me CH4, and some students will ask here a doubt. So CH4 means there is one carbon atom. There is no meaning in saying from the adjacent or from the same, correct? So there are 2 possibilities for this one. That means from here only I can remove the 2 hydrogen atoms. So this becomes a bivalent radical. So what will be the name of this? It can be named in 2 ways. It can be either we can say methylene, because from the same carbon atom 2 hydrogens are replaced, or methylidene. Both are correct. Okay, or methylidene. Understood? Only in this case, because from the next one, ethane onwards, there are 2 carbon atoms are there. So we will see the example of ethane. We have seen that in our initial case. Okay. So tell me what are the 2 possibilities, 2 possible bivalent radicals out of this. I can say CH3, CH. So from terminal carbon, 2 hydrogen atoms are removed. Now what is the name of this one? You know, this will be ethylidene. Now what is the other possibility? Tell me. It can be CH2 hyphen CH2. This can be from the 2 carbon atoms, nearby carbon atoms. I am replacing one hydrogen. So what is the name of this compound? I can say this is ethylene. Okay, so don't get confused, this is very important. So this is called ethylene. Now we will take the third one, that is propane, and we will try to see the bivalent radical. Okay, so let me rub this. Okay, so I will take propane CH3 and we will try to see the possibilities. So from the propane, again I am from the terminal, I am trying to remove the two hydrogen atoms, CH3, CH2, CH2, like this. Now can you tell me the name of this compound? This will be what actually? Tell me. So this will be called normal propylidene. Why? From the same carbon atom. And why we are saying normal? Because more than branching is also possible. Okay, now the next possibility, from here I have removed, and from the central carbon atom also we can remove two hydrogens. So what can be the structure then? In that case, CH3, CH3. Now tell me, what does it look like? I will draw it in another way, then you will easily get it. CH3, like this. Now you know that there is this CH3 linkage is there. So what should be the name of this compound? So the name of this compound is isopropylidene. Isopropylidene, correct? Because from the same carbon atom, two hydrogen atoms are replaced, correct? Now, is there any other possibility? Yes. What is that? I will draw that also. The third possibility is one hydrogen atom from the central one and other from here. So I can say the third possibility is CH3, CH2, like this. So what is the name of this compound? I can say its name is propylene. Propylene, correct? So I hope you got a fair idea regarding the bivalent radicals and how it should be named. Now we will see some exceptions actually. There are some unsaturated bivalent radicals that you should know. Unsaturated radicals, that is very important. Those are having special name also. Okay, so we will see that. Okay, so I hope until now it's clear for you. And if you have any doubt, feel free to ask the doubt in doubt clearance session, and also you can also ask me by putting the same doubt in the WhatsApp group. Okay, so it becomes easy for you also to understand. Now we will see some of the exceptions. Now what is the name of this compound? CH double bond CH2, okay, and okay, sorry, yeah, like this, CH2 double bond CH hyphen. So what is the name of this radical? Or sometimes they will draw like this also. This we will see in the chapter alkyl halides. CH2 double bond CH. So one valency is free. So this radical is called, please learn that, vinyl. You need to remember vinyl. And there is another special one, that is called CH2 double bond CH. Okay, CH2 double bond CH, CH2. And what is the name of this radical? This is a special case. So this is also called allyl radical. What is that? Allyl. Okay, these two are very important. The third one is not that important because these two are mentioned in your textbooks. We need to learn. The third one is when triple bond comes, CH triple bond C, okay, then CH2, like this. So this is called propargyl. So this is called propargyl. So these three are special cases, unsaturated, because double bonds are there. So when it is CH2 double bond CH hyphen, it is called vinyl, and CH2 double bond CH hyphen CH2, then it is called allyl. And if it is triple bond is coming for allyl, very simple, double bond replaced by triple bond, then we call it as propargyl. Okay. So next we will try to see what is trivalent radical and its way of naming, and some aromatic radicals also, that is also very important. Next we will try to see the naming of the trivalent radical. So what is basically a trivalent radical? In a trivalent radical, 3 hydrogen atoms are replaced, correct? So for example, I can say an alkane, okay? From this, if 3 hydrogen atoms are replaced, minus 3H are replaced, then this becomes a trivalent radical. Trivalent radical. Okay. Now, what will be the name given to this such a trivalent radical? It is called alkalidyne. Alkalidyne. Very simple. Since it is the 2 valencies are removed, we say dene. If it is 3 hydrogens are removed, we say dyne. You can compare this with a triple bond. Triple bond means yne will come, right? And double bond means ene will come. So you can remember, like when 2 hydrogen atoms are replaced, similar to double bond, then ene will be used. And if 3 hydrogen atoms are removed, then it is similar to the triple bond and we use the term dyne, alkalidyne. Okay. Now we will try to see one example and you should name the compound. Okay. CH3. What is the name of this compound? We know that with methane it is not possible. So we say CH3. From CH3 what we say? 3 hydrogen atoms can be replaced. So what is the possibility? So 3 hydrogen atoms are replaced means this will become CH3C like this. Correct? So what will be the name of this compound? I can say the name of this compound is ethylene. Why ethylene? Ethylene is coming because 2 carbon atoms. So ethyl. Ethylidyne. Okay. So ethylidyne. I hope it is clear for you. Okay. Now we will try to see some of the aromatic radicals. That is also very important for the exam. So let me say aromatic radicals. We will try to see some of the important aromatic radicals also. So I hope all these will help you in learning or understanding the organic chemistry in much better way, because as I have already told, naming part is the core area in organic chemistry. So once you are familiar with the naming of the organic compounds, it becomes very easy actually. You will understand why it is named like this and what is the mechanism behind it. So that's the reason why I am taking too much time for this chapter to make you understand actually. So once this chapter is clear, the other organic chapters are very simple. It's just a cakewalk. Okay. So we say aromatic radicals. Next topic, aromatic radicals. Okay. Aromatic means the first thing come to our mind is benzene basically, correct? So we will start with the benzene. So benzene is basically represented in this way. Okay. The other name of benzene is phene. Okay. Now listen. So from here I am replacing 1 hydrogen from benzene. So how it will become? C6H5. The formula of benzene is C6H6, correct? So from this, if I am replacing 1 hydrogen, it will become C6H5. Then this is called, can you tell me, if 1 hydrogen is replaced, then it is a monovalent radical. So for monovalent radical, we add the suffix YL, correct? So this will become phenyl. Clear? Okay, so this is represented in different way. Sometimes they will say it like this. Okay, or sometimes they will say it like this, but these notations are not very common. This you should remember, C6H5, or it can be like this one. Okay, both are correct, either C6H5 or like this, or like hyphen PH, or like Xi. All these are what actually? Phenyl. Now we will try to see another example. Okay. So listen, the examples are very important because that will help you learn the other organic chapters in a much comfortable way. Okay. So tell me, what is the name of this compound? We have learned these things, naming already completed. So tell me, what is the name of this compound? So we know its common name is accepted as the IUPAC name. The name of this compound is toluene, correct? toluene. Now there is radicals which can be formed out of this. So suppose one hydrogen is removed from this one, so it is like this. So CH2. Now can you tell me the name of this radical? So this is called benzyl. Please, you need to learn this. There is no format. You should learn benzyl. With the benzene, if there is CH2 group is there, we say it is benzyl. And you know that one more hydrogen can be removed out of this, then it becomes 2 hydrogen is removed total. So this will become what? I can say this will become like this. Correct? CH2 radical. Now tell me what is the name of this compound. You know that YL should be removed with dene. Correct? So this will become benzylidene. Benzylidene. And there is some another way of naming this. Some earlier scientists, they used to call this as benzal. You can use that also. Sometimes you would see that in the question paper. It is either called benzylidene or benzal. And you know that if one more hydrogen is removed from this, correct? If one more hydrogen, so totally 3 hydrogen is removed. So in that case, what it will become? You will have benzene ring with C, and there is 3 valency left behind. So what is the name of this compound? You know that if 3 valencies are there, it's a trivalent radical. So benzylidene. So we can call this as benzylidene. Okay, or there is a common name similar to benzal. It is called benzo. It is also called benzo. So very simple: benzyl, benzal, benzo, or benzyl, benzylidene, or benzylidene. Okay. So these are the various things. And why I am teaching you this is, sometimes you will see in some question papers, what is the name, common name of this compound? They will say like this: CH2OH. Okay, so I am asking you the common name. Then they will call this as with the common name. You know, this part is what? Benzyl, and OH means it is alcohol. So this is known by the common name benzyl alcohol. Understood? So whenever some in question paper they say benzyl alcohol, you should not get into confusion. This is how you need to draw the compound. So that is why I am telling you need to learn this. That will help you in understanding organic chemistry in a much better way. Now in the next session we will try to see the classification of organic compounds. I haven't taught you up to now. So we will see the classification, and we will try to see hybridization and aromaticity in much more detailed way. Okay? Okay, so next we will try to see the classification of organic compounds. Actually this should be taught first, but okay, I felt like first you should name the understand the name of the organic compound. Then only we will learn the different classification. Okay, so let's say I will put the broad heading organic compound. Organic compound. So organic compound can be broadly classified into 2. That is, I can say it like this. So the main broad classification. So the first one we call it as open chain compounds. We say open chain, or it is also known by another name, acyclic. Acyclic means what? Not cyclic, because A is there. Acyclic, or it is also called aliphatic compounds. Aliphatic compounds. Okay. Now the next broad classification, then you will understand it, because if it is open chain, then the other one should be what actually? It should be closed chain organic compounds. So the other area we say it as closed chain organic compounds. So closed chain organic compounds can also be called as what actually? Cyclic. Understood? Cyclic organic compounds. And coming to the first one, this is further classified into 2. So we say this is further classified into 2. That is, first one we call it as saturated. Saturated. How you say? Saturated open chain or acyclic or aliphatic organic compounds. And the next one is unsaturated. Unsaturated. Now how you will say this one? Unsaturated open chain organic compounds. Now saturated, in that the example is alkane, and its formula you might be knowing, CnH2n plus 2. And in unsaturated, it is further into two. One is double bonded, that is alkene. Its formula is CnH2n, and the other one is alkyne, that is CnH2n minus 2. Correct? So these are the classification. Now coming to the closed chain, that is very important. Okay. So coming to the closed chain organic compounds, it is further divided into two. One is called homocyclic and the other is called heterocyclic. So we can say one is homocyclic closed chain organic compound, or the other one is called heterocyclic closed chain organic compound. Okay, now you should understand the meaning of homocyclic. Homo means homo, all means homo means same, homo sapiens. So the term homo means same. That means, let me say, for example, if I am drawing a cyclic structure, okay, consider this is a closed chain compound, and if the ring is made up of only one type of element. Now you can see here carbon connected to another carbon, this carbon is connected to another carbon, and this is connected to another one, this is connected to another one, this is connected. So whole ring structure, please understand only the ring structure. Maybe this may be connected to hydrogen, that is not our problem. But the ring structure is made up of only one type of element. In that case we use the term what? Homocyclic. Please understand that, very very important. Now let's try to understand what is then heterocyclic. Heterocyclic means very simple. Suppose in the ring structure, if there is another element coming into picture, for example, you could see here in the ring structure, here everywhere carbon, but in the ring structure here nitrogen is there. That means more than one element is present in the ring structure. In that case, we use the term heterocyclic. What it is? Heterocyclic. So I hope you understood what is the difference between homocyclic and heterocyclic. Now this homocyclic itself is classified into two. Okay, homocyclic itself is classified into two. One is called alicyclic. One is called alicyclic. So how will you say this compound then? Alicyclic, homocyclic, closed chain organic compound. Then the other one is called aromatic. Okay, so how will you name this compound then? Aromatic, homocyclic, closed chain organic compound. So similarly, heterocyclic is also classified in the similar way. This can also be, okay, there is no space, I am drawing in big. So this can also be the same way, alicyclic, or it can be aromatic. Okay, so here how will you say then? Alicyclic, heterocyclic, closed chain organic compound. Understood? Now I need to explain what is alicyclic and aromatic. Okay, let me say, to say whether a species is aromatic or not, I have some definite criteria are there. That is what we are going to learn next. Now alicyclic means very simple. These closed chain organic compounds are having similarities, having similar properties to whom aliphatic compounds. So these are alicyclic, homocyclic or heterocyclic. Closed chain organic compounds are those compounds which resemble the properties of what? Aliphatic compounds. So such a type of compounds are called alicyclic. Then your question is, sir, how we will identify, sir, whether it is alicyclic or not? By looking at it, not possible. But I can say, to identify whether a given compound is aromatic or not, there are some criteria are there. That's what we are going to learn. That is the criteria which is required to determine whether a given compound is aromatic or not. Okay, so here itself aromatic is further they may say non-aromatic, anti-aromatic, like that they used to say. That is also correct. This is further classified actually. This can be aromatic, it can be non-aromatic, or it can be anti-aromatic. We will try to see those examples also. So I hope the classification is very much clear for you. So next we will try to see how to check whether a given compound is aromatic or not. Okay. Okay, so this is one important area. So I will mark this as very important because this is a repeated questions for Neet as well as JEE or anywhere. Okay, so whenever it is that area is coming for Neet exams, it's very important, then I will mark it as important. Okay, that is for your convenience. You can also mark it in your notebook. Okay, so here condition for aromaticity, that is the topic. So this is also known by the name Huckel's rule of aromaticity. So Huckel, he stated that there are 4 criteria that you should follow for a compound to be aromatic in nature. The first criteria is the compound should be cyclic. First condition, it should be cyclic. Cyclic means what? There should be no starting or ending. It should be always connected together. Correct? The next condition is the compound should be planar. What do you mean by planar? That means all the atoms or at the structure, the basic ring structure that is connected, that should lie in a single plane. Single plane means we know there are different planes are there. For example, if you take this duster, I can say this is the horizontal plane of this duster, correct? And if I keep this duster like this, I can say this is the vertical plane of this duster. And if I say put it like this, I can say this is a horizontal with the vertical. It's an inclined plane. Okay, so if somebody says that an organic compound should be planar, means the ring structure, that is the carbon atoms or the atoms that is connected in the ring structure should lie in a single plane. That plane can be inclined plane or horizontal plane or vertical plane, but it should be in one plane. It cannot be like one of the carbon atom is in vertical plane and the other carbon atom of the structure is in horizontal plane. Not possible. It should be in one single plane. Now most of the students ask here a doubt, sir, how we can know that? Because all the structures we are drawing in our paper, which is nothing but a horizontal paper. It's a horizontal plane, or it's a 2-dimension. Then how we know that whether all are lying in different planes or not? The answer for that is we need to check the hybridization of that atoms which are connected in the ring structure. And if that atom is having an sp2 hybridization, what hybridization? sp2, then I can say we know that if sp2 hybridization is there, its shape is planar. How you know that? I will teach you in the chapter, or my colleague will teach you in the chapter chemical bonding. So meanwhile, you just understand if you have sp2 hybridization for the carbon atoms, then we say it is planar. Okay, next condition, it should have cyclic resonance. So here a big topic is coming into picture, resonance. I will explain you what is resonance, and it should have, right now I will teach you how to say whether a compound is having a resonance or not. So what is resonance means? We know that in chemistry every atoms are bonded together, and there are 2 types of bonds are there. Not 2 types, there are 3 types of bonds. Okay, the main type of bonds are, one is sigma bond and another is a pi bond. And we say the delocalization means movement, and movement of this pi bond or pi electron, the movement of pi electron is called what actually? Is called resonance, or we say delocalization. The movement is also used, we use the term delocalization because you are moving from your fixed place. Okay, so I can say the delocalization or the movement of the pi electrons of the pi bond is called resonance. Now the next question here is, sir, why the pi electrons are moving? Why can't the sigma electrons not moving? The reason for that is the sigma bonds are connected through axial overlapping, because you learn in the chapter atomic structure there are orbitals are there. Okay, and if these orbitals will overlap during the chemical bonding formation, so whenever these bonds are overlapping in an axial way, then you will get what is called as the sigma bond. And suppose the same orbitals are overlapping in an, what you say for this one, axial, this is called lateral. So if they are overlapping laterally, then we say such a type of bond is called a pi bond. Okay, usually we know that this type of bond, axial overlapping, it is very strong. You need to provide more energy to break this bond. But in the case of pi bond, which are formed by lateral overlapping, it is very weak. If you just give a small amount of energy, this bond will break. That is the reason why we say in resonance, which electrons will move? It is the pi electrons which will move, because pi bond is a weak bond. So I defined resonance. Resonance is nothing but movement of pi electrons of a pi bond is called basically what? Resonance. And I will explain what is cyclic resonance. Cyclic resonance means the resonance happening in a cyclic structure is called cyclic resonance. Okay. Now fourth condition is it should obey 4n plus 2 pi electron rule. So this also I will explain. So right now you can take down these 4 conditions and note down. So in the next class I will try to explain the same thing with an example. Then it becomes very much clear for you. Okay, because it needs more explanation. So it will take time. So I will do that in the next class. You can just note down these 4 criteria and rules, and we will see more examples in the next class.